I would like to attract your attention to several important movements in this lecture. At first, tension processes it's occur when we change any elements in the considered schematic, or we turn it on or turn it off source of electromagnetic energy, and we consider several time moments. First, t less than 0, then moment just before commutation, it is designated in such a way, moment just after commutation, designated in such a way, t greater than 0, it's period of transient processes, and t tends to infinity is period when transient processes is over, and considered schematic operates in a mode of steady state processes in a condition after switching. We should write down either current through inductance or voltage drop across capacitance as sum of forced and natural component. Forced component is determined just by character of a source. If character of source of electromagnetic energy is DC, forced component will possess DC character. If it is AC, it will possess AC character, and if source is disconnected after commutation, it will be equal to 0. Natural component depends only on type of circuit. It does not depend on type of source. And natural component, it arises due to inconsistency between energy stored in reactive elements such as inductance or capacitance at the moment in the mode before commutation and in the mode just after commutation. And there are two switching laws which should be fulfilled. First switching law, it's current through inductance cannot change immediately at the moment of switching. It retains its value as before, the same value as was before commutation. It retains its value just after commutation. Second switching law or switching rule says us that voltage drop across inductance voltage drop across capacitance retains its value at the moment just before commutation, and the same volume will be at the moment just after commutation. Such conditions are called independent initial conditions. Other parameters present themselves as dependent initial conditions because these conditions, for instance, voltage drop across inductance, current through capacitance, current through resistance, voltage drop across resistance, they called dependent initial conditions because they depend on the independent initial conditions. And it was shown to you how to deal with RL circuits. We can depict electrical processes by writing down such an equation. It's sum of voltage drop across resistance and across inductance, and solution, and it's equal to applied voltage. Solution of such equation, of such differential equation, may be written as sum of forced and natural component. Forced component, as I have told, depend only on the type of applied voltage or connected EMF, and natural component can be determined by solution of this equation with 0 right hand side part. And from mathematics you don't know such a solution, and it is written in such a form, all time in such a form, its integration constant multiplied by exponential function. And for RL circuit we have this coefficient in exponential function, its transient time constant is L over R measured in second. This is natural component. And you should remember that transient processes is considered um, as lasting up to moment t. Transient process is equal to approximately 4.6 of this integration constant tau L. It's graphs, and it was considered example of calculation of electromagnetic processes in such a schematic. Before commutation, its first location of this key, we have such schematic, and after commutation it will be this way. Okay, it will be before commutation. Current here, it is necessary for us to determine current at the moment just before commutation. At the moment t less than 0, it was equal to, for such a schematic, it was equal to E over R, because voltage drop across inductance in steady state DC process is equal to 0. It was light short-circuited part of this schematic. And after commutation, RL circuit will be disconnected from source, so forced component will be equal to 0, and natural component is written as A multiplied by integral minus T over tau L, and as forced component equal to 0, it will be IL will be equal to IL natural, and in such a form. Then from the first commutation law, we determine this integration constant by substituting in this equation t equal to 0. For t equal to plus 0, it will be 0 all the same. So it will be this exponential function for t equal to 0 equal to 1, 2 unit. So we will have only this a. And we do know that current before commutation was equal to E over R. So from here we determine this integration constant, okay? And time constant is determined as L over R, and we have IL, current through inductance after commutation. From here we can determine voltage drop across this inductance as L dIL by dt. Take this derivative from this function. Okay, and then their graphs are here. Then you see here current through inductance change smoothly at the moment of commutation, but voltage drop change abruptly to provide this smooth changing of current. And it may be shown that physical meaning of the tension processes is release of energy stored, magnetic energy stored in inductance before commutation, because current has been flowed through this inductance, and this energy stored, magnetic field energy stored, has been released as heating energy to heat this resistance connected in series with inductance. And physically, we always have had some resistance connected in series with inductance, because we have at least resistance of the connected wires. So this wires will be heated, and this stored energy will be released during such a heating. So please listen attentively this lecture. If you have any questions, please let me know. Please write me to my email address, which you know well enough, through Office 365, and ask me questions if any, and I will try to answer your questions. And please do your home tasks on you don't know your variants, you don't know you have this methodic material. I have sent you reference on this methodic material, and maybe I will do it again. And please start solution of your home task. Read attentively, please, this methodic material which depict in many details how this problems should be solved, and please use your own variant, and I have explained it many times to you how it should be done, and it is explained in this methodic material. Please don't ask me how to find your variant, because it is, if you read this methodic materials attentively, you will find answers on all your maybe existing future questions. So study, study and study. It was very nice to give you such a material. Bye bye for now.